Tunnels, a miracle of modern engineering. They make mountains manageable, connect our cities, and can even bring together continents. Places of mystery and adventure, and occasionally, catastrophic disaster. Since the tunnel building boom of the 1960s, the world has become a very different place. More people, more trucks, more traffic, more accidents. The past decade has seen tunnel disasters that have spelt destruction, chaos, and even death.
Sie sind alle in den ersten 10 Minuten erstickt.
We all got out on the Italian side. The people on the French side were not so fortunate.
While investigators pick through the ashes to find out what went wrong, the engineers of new tunnelling projects figure out how to put it right.
We have to eliminate catastrophic failure.
Across the world, the modern tunnel is built from disaster. Tunnels bring people together, connecting towns, countries, and even continents. But the world's tunnels are under pressure. As more traffic and freight passes through them, accidents are on the increase. 1999, a burning truck was abandoned in the Mont Blanc tunnel that connects France and Italy. 39 people died. In 2001, a truck collision in the Gotthard tunnel caused a massive fire. 11 people died. 1996, a burning cargo train caused the lining of the Channel Tunnel to explode. Serious structural collapse.
They said that the concrete was falling on them like shrapnel.
From each event come crucial lessons in tunnel design, revised approaches to evacuation and fire control, new construction techniques to prevent tunnel collapse, fresh ideas about accident prevention. Across the world, new tunnels are being built from disaster. One of the most innovative new tunnelling projects is the Marmaray Tunnel, under construction in Istanbul, Turkey. At an estimated cost of $3.5 billion, the 13.6-kilometre-long tunnel system will run 58 metres under the Bosphorus Straits. It will be the deepest immersed tunnel in the world. Istanbul needs the tunnel badly. It has a population of 12 million and terrible traffic problems. It will take the pressure off the Bosphorus Bridge and will be the first tunnel connection between Europe and Asia.
The Marmaray project will make the lives of the Istanbul citizens more comfortable and will save them a lot of travel time.
The tunnel's designers have much more to consider than commuter comfort and reduced journey times. Their biggest challenge, as for any tunnel construction, is how to overcome fire, a tunnel's single greatest threat, as recent disasters have shown. On March the 24th, 1999, 2,000 kilometres away across Europe, a sequence of events began to unfold that was to have fatal consequences and would influence the design of all new tunnels to come. At 10:46 in the morning, a heavy goods vehicle entered the 11.6-kilometre-long Mont Blanc tunnel, which connects France and Italy. 6.7 kilometres inside the tunnel, the driver was shocked to discover his truck was on fire.
J'ai regardé mes rétroviseurs et j'ai vu de la fumée du côté droit. Je suis sorti du camion, et la fumée était déjà beaucoup plus importante. J'ai voulu prendre l'extincteur, mais je n'ai plus eu l'occasion parce que ça a éclaté en feu, toute la cabine.
The driver abandoned his vehicle and managed to escape, but he left behind a disaster in the making. A burning truck with a highly flammable cargo. One of the drivers also using the tunnel that day was British trucker John Whitby.
In a period of 18 months, I probably used the Mont Blanc about 40 times. It was a dark, depressive type of tunnel. It seemed to go on forever.
Whitby entered the tunnel on the Italian side, en route for France.
I was driving for about 5 minutes into the tunnel, and then we started to get traffic approaching that was flashing its lights.
Moments later, around 40 vehicles were forced to a halt, including Whitby's truck.
We stopped, we got out of the vehicles, and we were looking down the tunnel to see what was going on ahead, whether it was roadworks or whatever, and it was all black. So we just assumed that the lights had gone out further down the tunnel.
Within minutes, the Italian emergency services began to arrive.
The fire brigade came roaring into the tunnel, and they shot straight past us, sirens going, and just disappeared into this wall of blackness. And it was only about then that we started to think, well, that black might just be smoke.
The abandoned truck was carrying margarine, highly flammable, and by now burning hot and fast. As the tunnel filled with smoke, there was a series of loud explosions.
Like a field gun in the distance. We've got a fire on here. There's that's truck tyres exploding. The entire tunnel actually shook. The road shook under the feet. You felt the air vibrate and the walls shake.
Whitby and others near him were rescued by an Italian fire engine, forced into retreat as the fire escalated.
And we all got out of there at a very rapid rate of knots.
Those nearer the French exit were less fortunate. The smoke surged towards France, stopping the French fire team from entering.
Et à leur arrivée, il y avait déjà plusieurs kilomètres de tunnels enfumés. Et les premiers intervenants ont été bloqués dans le tunnel.
The drivers on the French side of the blaze were trapped, enveloped in thick smoke.
The lucky ones died in the cars. They probably 2 lungfuls of the smoke and they were dead. It was that toxic and that thick.
Some drivers on the French side managed to leave their cars for the supposed safety of the tunnel's fire refuge cells. But these were designed to deal with a small car fire, burning at 800 degrees centigrade for only a few hours. At Mont Blanc, the fire blazed at 1,000 degrees centigrade for 53 hours.
And these poor people were basically cooked inside the safety cell. And I honestly cannot think of a worse way to die.
It took 5 days for the tunnel to cool down before the fire services could enter. They were horrified by what they found.
Pour l'incendie du tunnel du Mont Blanc, il y a eu des températures jusqu'à 1000 ou voire 1200 degrés qui ont été atteintes dans certains secteurs du tunnel. Et donc, en arrivant sur les lieux du sinistre, après avoir refroidi la voûte, nous avons découvert progressivement plusieurs dizaines de véhicules totalement calcinés, puisque, je le répète, les températures sont montées à plusieurs centaines de degrés, voire à 1000 degrés. Donc, des restes de véhicules, de tôles, de carcasses de véhicules sur plusieurs centaines de mètres de long. Et notamment sur 600 mètres, même l'asphalte de la route avait fondu et brûlé.
Of the 50 people caught in the fire, 39 died.
When I think back now, I was probably one of the 11 luckiest people in the world. It's an experience that will never ever leave me, because those people shouldn't have ever died. None of them should have died.
The Mont Blanc fire was a tragedy that drew worldwide attention. An investigation began into what had gone wrong. Part of the answer lay in changing times. Built in 1965, the Mont Blanc road tunnel was designed to carry light traffic, not heavy goods vehicles. Wind forward to the late 1990s, and a different world uses the tunnels of Europe. Part of this new economic order is the container truck, often carrying flammable materials. The old Mont Blanc fire refuges and ventilation system simply couldn't cope with the intensity of a modern truck fire. Since 1999, the Mont Blanc tunnel has been redesigned and refitted along its entire length. When the truck caught fire, smoke and toxic fumes rapidly accumulated in the tunnel, with catastrophic consequences. As atmospheric pressure was lower on the French side than the Italian side, the smoke surged towards France. The Italian control center switched on the fans to blow the smoke through, but instead of clearing it, they simply fed oxygen to the fire, making it burn hotter and faster. The tunnel's refit has adopted an innovative system, which it's hoped will prevent history ever repeating itself. 116 new ceiling fans have been fitted along the tunnel. The fans maintain an area where wind speed is 0, the point depicted by the yellow line. This zero wind speed zone can be manipulated remotely to control the movement of smoke. In the event of a fire, the fans direct the still zone to the area of the blaze, allowing smoke and fumes to be removed through extraction vents by powerful ventilators. At the same time, the new ventilation system brings fresh air into the tunnel.
In this very large technical room, you have two kinds of turbines. You have on my right hand, you have the blue one in place to pump the fresh air from outside and to push it inside the tunnel. So fresh air is very cold and they don't need special protection. But here you have the red turbines. These turbines are protected. They are here to extract the smoke and extract the hot air in case of fire inside the tunnel.
With the smoke under control, the rebuild addresses the provision for refuge and escape. The old fire rooms along the edge of the tunnel were death traps, quite unable to cope with the ferocity of a high-intensity blaze. The escape system has been entirely rebuilt, with new safety shelters capable of withstanding heat up to 1,000 degrees centigrade for 4 hours.
Okay, I'm entering now in the safety shelter. The safety shelter is a place where you are completely safe. The only thing you have to do is to wait for further instructions. And the further instruction will come through this video system. And through this video system, I'm able to enter in contact with the operator. I push.
Hello?
Bonjour. We are in the shelter number 16.
Yes, you are there and now you wait there.
Okay.
Our rescue team will be arriving in 2 minutes.
Okay. So the operator said me that I have to wait here for the rescue team, and the rescue team will come through this door.
The key innovation in the new rooms is that this time they're connected to an escape tunnel that leads to the French and Italian exits.
To the escape corridor, and you follow me. Normally, the rescue team will open the door, and we are now under the way, and you have Italy here and France here.
The new Mont Blanc tunnel is an old structure that has been rebuilt, but it will never be risk-free.
We will never say that. We did the maximum to avoid terrible consequences to an event. But nobody can say that we will never have an event in the tunnel.
180 kilometers away in Switzerland, the brand new Loschberg tunnel has also learnt lessons from the Mont Blanc road tunnel disaster. Opened in 2007, it's a dual-bore rail tunnel. The escape system here is on a grand scale, capable of dealing with 1,500 passengers. Loschberg is the third longest tunnel in the world at 34.6 kilometers long, 3 times the length of the Mont Blanc tunnel. To cope with the size, here the ventilation system is colossal, built to deal with a high-power fire reaching 1,000 degrees centigrade.
So we're here in the ventilation center of the Loschberg base tunnel. There are 2 such centers, one here, one 50 kilometers north, with 2 ventilators. Each of them can pull 200 cubic meters of fresh air into the tunnel system. This ventilation system is crucial for the security in the Loschberg tunnel. It's used to take out polluted air in case of a fire from the railway tunnel tubes and takes it outside. Here we see how fresh air from outside is brought through these noise-reducing walls into the ventilator and is pushed with force into the tunnel. It's now running only at 25% of its capacity. In case of an emergency, if it would run full speed, it would burst our ears. But now it's quite quiet, that's why we can still talk.
Loschberg also addresses the need to get the emergency services in as quickly as possible. At Mont Blanc, the firefighters were obstructed by the heat, smoke and darkness. Here, the system boasts the ultimate in early response, the fire train.
Also bei einem Alarm, Brandalarm, wird es 5-6 Minuten gehen mit beiden Wasserwerfern. Und dann lassen wir knapp bei 5000 Liter raus und haben 50 Kubik dabei, also das ist relativ schnell, wäre es leer.
The train isn't just about fighting fires, it's also a mobile hospital.
Der Zug zu trennen in Löscheinheit und Rettungseinheit. Mit der Rettungseinheit können wir einen Shuttle-Betrieb machen. Also das heisst, wir können Leute aus einem Gefahrenbereich rausbringen.
But even this system has limitations. In the most intense heat, above 1,000 degrees centigrade, there's little even the most rapid response team can do.
Und dort ist das Limit ganz sicher Hauptaugenmerk auf den Menschen. Was kann der Feuerwehrmann oder Frau, was können sie noch schaffen? Können sie noch schaffen oder gar nicht mehr? Und dort ist die Limite. Dort muss man dann auch den Mut haben, sagen, es ist nicht mehr bekämpfbar und den Rückzug nehmen.
In Turkey, the Marmaray project has taken the lessons from Mont Blanc to the extreme. Although this tunnel will be relatively short, just 1.5 kilometers between the stations on either side of the Bosphorus, its ventilation system will be the most powerful in the world. And this is where they're going to put it. The Serkeci Deep Station. This massive ventilation chamber is only a small part of the huge station complex under construction. Chief Engineer Melir Babur is in charge of the design of the ventilation systems.
Okay, we are at the west ventilation shaft of Serkeci station. The total shaft length is around 200 feet.
As always, the key to any ventilation system is to have control over the smoke in the tunnel.
And we want the smoke to move in a certain direction so we can have the passengers evacuate in the other direction. This is the main purpose, okay? There are going to be about 7 different levels, equipment levels, and each level will contain different equipment. Most of them are dealing with the emergencies, like tunnel ventilation funds will deal with emergency situation. The main purpose here is to reduce the risk of fire, and when the fire starts in that unfortunate case, to put aside the adverse effect of the fire.
As in Loschberg, there will be ventilation plants at each end of the tunnel, one in Europe, the other in Asia, with one set of fans sucking air out, the other pushing it through. The lessons of the Mont Blanc disaster were swiftly learnt and rapidly implemented. But despite this, only 2 years later, another alpine tunnel disaster was to horrify Europe. The Gotthard road tunnel connects Switzerland and Italy. When it opened in 1980, unlike the Mont Blanc road tunnel, the Gotthard tunnel was already equipped with a state-of-the-art fire detection and evacuation system and was considered the safest in Europe. But refuge cells constructed every 250 metres of its 16.4-kilometre length and an advanced tunnel ventilation system weren't enough to prevent the tragedy to come. On October the 24th, 2001, two lorries travelling in opposite directions collided 1.5 kilometres from the Italian entrance. A ruptured fuel tank immediately ignited. Vehicles travelling in both directions on either side ground to a halt. Urs Gerber was caught in the jam.
Coincé, donc j'ai arrêté le moteur. Je suis sorti et puis je suis allé contre la mur, donc direction nord. Et là, tout d'un coup, c'était sombre.
As the fire took hold, wheels exploded in the heat and toxic smoke filled the tunnel.
J'entendais des petites cris et puis des petites explosions, mais à ce moment-là, c'était comme, faut dire, comme un rêve. Alors je voulais pas mourir, et puis pourtant je sentais que j'arrive plus à respirer comme il faut. Donc.
Gerber and 4 other drivers couldn't find the escape room, and the air was running out. They were trapped.
Pas plus, donc, parce que c'était seulement la volonté de survivre qui m'a tenu en vie.
By chance, one of the group managed to locate an exit.
Il a ouvert la porte, et puis à ce moment-là, c'était clair, et puis on était sauvés, on peut dire. Hein?
Not all the people caught in the tunnel were as lucky as Gerber. Walter Steiner was tunnel controller on the day of the fire.
Es gibt Chauffeure, die sind mit dem Rauch geflüchtet und konnten den Schutzraum noch erreichen. Und das haben aber nicht alle geschafft, sondern sie haben den Eingang zum Teil nicht mehr gefunden oder sind zum Teil im Fahrzeug geblieben. Sie sind alle in den ersten 10 Minuten erstickt aufgrund der toxischen Rauchgase.
In all, 11 lives were lost. After the tragedy, steps were taken to improve the emergency lighting system, making it easier to find your way through dense black smoke. But shocked that lives were lost, despite the state-of-the-art systems already in place, designers now focus their attention on trying to prevent accidents happening in the first place. One innovation was to monitor and control the volume of heavy goods vehicles entering the tunnel at any one time. An automated system was put in place to drip feed a maximum of 3 trucks per minute into the tunnel. Using a traffic information collector, operators not only monitor the speed of vehicles, they ensure that vehicles are kept apart.
Nach diesem Unfall hat man versucht, mit einem System die Lastwagen auseinanderzunehmen, größere Abstände zu bilden.
Before the accident in 2001, there were 45 vehicle fires in the tunnel every year.
Heute mit dem System sind es nur noch 10. Also 10 pro Jahr.
The Gotthard team went a step further. They wanted to solve the problem of how to prevent spontaneous combustion of the sort that had caused the catastrophic fire at Mont Blanc. At the Gotthard tunnel, a new technology is being introduced that will combine three-dimensional thermal imaging cameras with the traffic control system.
This object you see is car transporter. You can measure this object, you can do everything with it. This is the base for all our applications.
The next step is to take a thermal scan and drip it over the 3D object.
We see here that it's a hot spot here at the end of the vehicle. Whenever we see, okay, that's the one which we think it's too hot, and then the operator has to react, and he has to go on and has to pick it up out of the traffic. In the Gotthard tunnel, there are multiple fires every year. We can reduce this number of fires by 80%. Then we have a huge advantage.
Through traffic control and early fire detection, it's believed that the Gotthard tunnel will be less exposed to another killer fire. In recent years, many of the big tunnel fires resulting in loss of life have been in a road tunnel. Vehicles, and especially large vehicles, trucks and lorries, are travelling bombs primed with fuel, sometimes carrying highly volatile cargoes, subject to spontaneous combustion and vulnerable to driver error. One answer to some of these issues is to completely replace road with rail. The new Marmaray project in Turkey is a rail tunnel. All freight will be carried by train, not by truck. 2 separate tunnels, one in each direction, prevent the risk of the trains colliding. And by eliminating heavy goods vehicles altogether, the tunnel's designers have taken on the lessons of previous disasters. But even train tunnels can be plunged into chaos by major accidents. In 1996, the Channel Tunnel that connects England and France revealed a frightening weakness in its design. It was the most advanced rail tunnel of its type, built as 2 tubes with a separate rescue tunnel and crossings at every 300 metres. It was thought to be the safest tunnel in the world. It runs through the chalk seabed that lies under the English Channel, connecting England and France. At 9:48 p.m. on the 18th of September, a Eurotunnel cargo train entered the Channel Tunnel at Sangatte, near Calais, northern France. On one of the trucks in the cargo section of the train, a fire was smouldering. The fire spread to the train, and 19 kilometres inside the tunnel, it suddenly stalled. The blaze was soon out of control. In the smoke-filled darkness, the train's 33 passengers and crew were led towards the safety tunnel by the fire services. It was a narrow escape.
We couldn't see because the smoke was getting into our eyes.
I thought I was going to die, I really did. I was laying on the floor, everything was going, lightheaded. I thought I'm going to die here.
The passengers were safely evacuated, but the fire couldn't be controlled. It had already reached critical temperatures over 1,000 degrees centigrade. The concrete tunnel lining began to spoil, falling away in huge chunks. At the heart of the fire, the lining was almost completely lost. Luckily, the tunnel was running through a dry part of the seabed. If there had been water on the other side of the lining, there would have been a catastrophic flood. Professor Gabriel Alexander Coury of Imperial College London has studied the 96 Channel Tunnel fire.
Half the section was destroyed, and in some parts, the spalling took place all over the section, right up to the ground. Now, that is structural damage. 500 meters of the section was damaged, of which 50 was serious, and that is in terms of the explosive spalling of concrete.
The tunnel was lined with high-strength concrete, where additives like fly ash create stronger chemical bonds in the concrete mixture. At the same time, the amount of water is reduced, which also increases strength. But in the Channel Tunnel fire, even this small amount of water became a hazard, turning to steam in the intense heat. The water pressure rose as high as 100 times atmospheric pressure.
The steam pressures will build up faster than they can be diffused, and there is a risk of an explosion taking place.
In the high temperatures, the lining of the tunnel literally blew itself apart.
And the firefighters in 1996, they said that the concrete was falling on them like shrapnel.
After the 1996 fire, Eurotunnel repaired the damage using the same high-strength concrete lining. But they upgraded their fire and rescue services in the tunnel, a strategy that withstood the test of another serious fire in 2008. Even though this type of concrete is now known to explode in intense heat, it's still in use in tunnels across the world. Some tunnels, like the Loschberg Base Tunnel, are immune to the threat of collapse. Because of this, the Swiss Alps, made of hard granite.
We have a stable rock structure, so there's no risk of a breakdown of the tunnel. Even if this concrete here would burn down or break, the tunnel would not break down completely. So this is a risk that we can almost exclude.
But 2,000 kilometers away in Istanbul, the Marmaray Tunnel doesn't have the protection of granite. It's lined with high-strength concrete, but lessons from the Channel Tunnel fire have been taken on board.
In the history, there are that sort of accidents which happened both in the highway tunnels and also the railway tunnels. And Channel Tunnel fire is one of the most serious examples in the past. So based on that, of course, we took lessons.
The concrete used to line the Marmaray Tunnel is protected with a fire insulation layer.
And there will be an application of fire insulation material depending on the ground conditions, the rock quality, whether we are in the fracture zone, the groundwater level, because we have to eliminate catastrophic failure and we have to prevent flooding.
The tunnel boring machine is a 150-metre-long complex that removes the rock debris from the drilling face at the leading edge of the tunnel.
We are at the end of that TBM5. We have, as I have mentioned, excavated 2 kilometers until now. And you may see that cutter head, which is the main part of the TBM machine you see there. These are the pistons which are located at the periphery of that cutter head, which has on the order of 75,000 kilonewton thrust force, which pushes the ground like that. So this machine is manufactured specifically for Marmaray project, considering all the soil conditions, the strength of the rock, etc. We will connect to the IMT, the element number 11 at the Asian side. So the IMT element and TBM will connect to IMT. We will do all these water insulation works and the inner concreting works, and at the end we will be able to have the full tunnels under the Marmaray project.
Fire is not the only threat to the structure. This huge tunnelling project is only 10 miles from the North Anatolian fault line. For Deputy Project Manager Hussein Belkaya, structural failure and flooding of the tunnel due to earthquakes is a very real hazard.
The occurrence of a big-scale earthquake in the next coming 30 years in Istanbul is 62%. This is really very high percent.
Like the Channel Tunnel, the Marmaray Tunnel runs through the seabed. Flooding is a real and potentially catastrophic risk. It's a threat that was brought vividly to light 2 years into construction. At one of the stations that will link the tunnel system together, they unveiled the remains of the ancient harbour of Byzantine Constantinople. Complete with 32 warships, this was one of the greatest archaeological discoveries in Turkey's history. For archaeologist Doğan Perinçek, the dig also offered up an environmental warning from history.
This excavation area has many chapters, and within this marshy sediments, we have some sediments related to flooding. What caused this? What's the reason of this?
For Doan, the key to unlocking the mystery lay in the historical records of Byzantium. In the 6th century, there had been 3 major earthquakes, and the new evidence of flooding pointed to one of earthquakes' lethal side effects: tsunami. 1400 years ago, a giant wave had devastated the port.
Earthquake during the 6th century and related to tsunami destroyed many things in the region. And the part of the harbor destroyed, and also wall of the city destroyed. And same tsunami destroyed the piers located within the harbor.
Tsunami modelling suggests the wave was between 6 and 8 metres high and had struck the port right where a crucial element of the tunnel was now being planned.
They are going to build a station here. And entrance of this station should be 6 or 8 meters higher than present-day sea level. Otherwise, will be disaster.
The tunnel's designers took their history lesson to heart and raised the height of the station entrances to protect the build against a future tsunami.
We have to be very cautious, and we have to take lesson from the past.
In a dry dock 40 kilometres from the Bosphorus, the 11 segments that will connect east and west are being constructed. A single segment weighs 18,000 tonnes, and at around 150 metres, each one is longer than a football field. The tunnel is itself designed to absorb the impact of an underwater earthquake, measuring up to 7.5 on the Richter scale.
Şu anda üzerinde bulunduğumuz tüp elemanı, boğaz tüp geçiş elemanlarının içerisinde sonuncusudur. En sonuncusu bu eleman, 11 numara. Boğazda batırılan bu parçalar, boğazda şu elemanlar aracılığıyla, şu contalar aracılığıyla birbirine bağlanıyor. Birbirine sızdırmaz hale geliyor. Ve ortaya çıkan bu 1400 metrelik tünel hattının sismik jointleri var giriş ve son uçlarında. Dolayısıyla bütün bu sistem depremde yarım metre hareket edecek şekilde inşa edilmiş olmaktadır.
Inside this segment, Adnan makes some last-minute checks before it's submerged. It will be floated into position above the drop location, where a series of ballast tanks will be filled to sink it to the seabed. For Adnan and his team, this isn't just a piece of engineering, it's an historic moment.
Böylece İstanbul Boğazı'nın altından ilk kez bu büyüklükte bir tünel, bir geçiş sağlanmış oldu. Bu belki 200-250 yıldır insanımızın bir hayaliydi. Bu gerçekleşmiş oldu. Tam bu nokta işte, bu tüneli Avrupa tarafına bağlayan ucudur.
In addition to seismic joints, the tunnel designers have ensured that the tunnel will not be damaged by liquefaction. Geologist Dr. Orhan Simcek has identified the problem areas.
This is a geological longitudinal profile of the Bosphorus channel along the immersed tube alignment. This is sea level, this is seabed level, this is rockhead level, and this is immersed tube alignment. The yellow color, soft clay material, call it golden horn clay. Towards east, Üsküdar side, immersed tube foundation is made up of sandy material. During high seismic event, there is a risk of liquefaction potential.
The Asian side of the tunnel lies in sandy soil. An earthquake would be disastrous.
It is estimated that fault rupture in the same segment happen between 200 and 300 years, recycling. So the last major earthquake in the center of the Marmara Sea happened in 1776. So you come to the States. So it is a high probability to have a major earthquake during the service life of this project.
The solution is simple: to surround the tunnel in a coarse gravel lining. The dredging vessel is busy day and night. The gravel will insulate the tunnel from seismic shocks.
In order to avoid the liquefaction risk in the sandy soil, you have to drain the soil. To drain the soil around the tunnels, immersive tunnels, coarse-grained crushed stone is required to have voids to release the pore water pressure during the seismic event.
When a serious earthquake eventually strikes, the large voids in the coarse gravel cladding around the tunnel will release the pressure build-up, protecting the structure. Simple, but effective.
This relaxation of the pore water pressure will prevent damage from the earthquake.
The Marmaray project is in the final stages of its construction. Many of its fundamental design features will have been informed by past disasters. Post the Channel Tunnel collapse, the Marmaray project will be protected from fire by a layer of thermal insulation. From the Mont Blanc fire comes the most powerful ventilation system in the world to control smoke. And the archaeological lessons of history bring a system of seismic joints to resist the effects of an earthquake. Above all, the Marmaray system's engineers are determined to eliminate truck driver error. Under the Bosphorus, 2 parallel rail tunnels will carry only high-speed trains. Truck shuttle trains will eventually pass through the tunnel, but trucks with flammable loads have to cross the Bosphorus by ferry. Despite all the challenges to construction, the tunnel project is back on track and due to open in 2012. 10 of the 11 tunnel segments have now been laid. At a depth of 58 metres, the tunnel has to be able to withstand 6 times the atmospheric pressure at sea level. For the immersed tunnel project manager, Hideki Sakaida, the tunnel is a new silk route between Europe and Asia.
Then we are now walking towards the European side. So we can say now we are walking in the new Silk Road.
The east and west are almost connected. Tunnels are on the brink of a new era. In many countries, a new movement has begun that aims to use tunnel technology, not just to connect people and places, but to construct whole new worlds underground. Amsterdam in Holland is one city fighting a very modern battle for more space. The city is in crisis. If cars are prevented from entering the historic city centre, the local economy will die. If the crowding continues, the city could become a polluted wasteland. Civil engineer Bas Obladen has a vested interest in solving the problem.
I was born in Amsterdam, and when I was young, that's so 60 years ago, it was a very nice town to be and to live there, and the quality of life was also very nice in those days. And say 8 years ago or so, I went with my son. I said, I'll show you the places where your father have been born and where he lived. I was shocked about what I saw. Everywhere there were cars and bikes, and it was terrible in my opinion.
Baz's vision is to remove cars from the roads and canal sides and, using tunnelling technology, take them below ground.
If the cars are, say, under the ground at the moment, then you get fresh air above the ground, so people are living longer, the quality of life is very nice, and alongside the canals there are no cars.
The idea is to funnel traffic from the ring road into an underground network of tunnels. Amsterdam's canals provide the blueprint.
We have a lot of canals in Amsterdam, so I'm using the canals for a road under the canals from the ring road to the underground system.
But tunnelling in Amsterdam is technically challenging.
The main problems in Amsterdam is, of course, the water level.
The engineers on the current north-south tunnel dig under Amsterdam are developing techniques that will help realise the new project.
Main challenge in this area is the softness of the soil. We have to try to maintain a stable environment for the drill to go through. So what we do is we drill 90-meter long poles that will be used for a brine solution that will cool down the entire soil and thus creating a frozen, like a permafrost layer through the total width of the 2 drilling machines.
As the technology has developed, so has the ambition.
The idea is not to make tunnels to a destination and then connect different destinations. So we say if you build a connection, why not make it a useful space? So it's all about really making a very big space. It's like the doubling of the floor space which is in the center of Amsterdam.
The design would not only provide much needed parking, massive underground spaces would house cinemas, squash courts and even swimming pools. Those behind the Amsterdam project are conscious that whatever the space is used for, safety lessons from past tunnel disasters still have to be applied.
For the fire safety, we are really looking into the possibilities of compartmentation and that you are always within a reasonable amount to walk to a safe place. So if something happens in your vicinity, you can like hold your breath and how many meters can I walk? Well, there would be a door. That is basically where we start from. And there are now materials which can really keep the fire on the other side of the doors.
For now, the Amsterdam dream of building urban spaces below the city streets is in the early planning stages. But in Turkey, the Marmaray Tunnel project is fast becoming a reality.
It is always difficult to construct a mega project in a urban, densely populated area. But once it is in operation, Marmaray project will save a lot of travel time and make the lives of more than 1 million passengers per day more comfortable.
Throughout its lifetime, the Marmaray Tunnel will face a double jeopardy of fire and seismic shock. But with the legacy of past tunnel disasters designed into its very fabric, it's being built to confront and overcome whatever challenges the future might bring.